Today we're going to for modeling behavior using quadratic functions to model data. Student works warm-up. All right, let's take a look at the next page. Getting started, that might be a bad idea. A 12-ounce can of soda was put into a freezer. The table shows the volume of the soda in the can measured at different temperatures. Describe the data distribution. As the temperature increases, the volume decreases and then increases. Create a scatter plot of data. Sketch a plot of points on the coordinate plane. Okay, go ahead and do that. All right, let's take a look at the next page. All right, activity 4.1, using quadratic functions to model data. Let's continue to analyze the data and make some predictions about the volume of soda at different temperatures. Use technology to calculate the regression equation that best models the data into the previous activity. Sketch the graph of the regression equation on the coordinate plane on which you created your scatter plot. Explain why the regression equation best fits. I don't think we need to do that. Okay, let's go ahead and get to the regression. So I'm going to go to Desmos.com. I'm going to go to Graphing Calculator. Statistics, linear regression, open graph. And then I need to remove the points. And we already know it's quadratic. So we're going to change this equation to be quadratic. Because it tells us it's going to be quadratic, okay? All right, so then that's 68. 50. 42.8. 39.2. 35.6. All right, now we don't see the graph, so I need to go to the tool key and adjust the window. And we need to use this. So we know it's going from 0 to 90, 0 to 357, okay? So let's go and adjust the window. So 0 to 90, 0 to 357. All right. Need to zoom out just a hair. Now you can see that the line goes to the points. The R-squared is not 1, but it's very close and close enough to accept it. And so then here's our equation. Here's our A value, B value, and C value that goes along with this equation. So then Y All right, so there's our equation. Now, say the domain range of function. And we just want the domain range of this problem. Now, domain is the lowest to highest number. So domain goes from 14 to 68, and the range goes from the smallest number, 354.88, to the largest number, 355.4. Okay, so go ahead and finish that up. So basically, we found the smallest number to the largest number. All right, let's take a look here. Now, use your regression equation to answer the question. Determine the y-intercept its meeting terms of this problem. So we need to graph the regression. So we're going to go over here, and we're going to go to Desmos, and we're going to go to graphing calculator, and y equals now again we want to adjust our window so we can see the graph better. So 0 to 90, and in this case I think let's go a little higher than 357. Let's go to 400. Okay, and and then our y-intercept is right there. Okay, the y-intercept is 0, 356.35. This is the volume of the soda when the temperature is 0 degrees. Okay, now if you look here, the graph doesn't cross the x-axis. Okay, so there are no x-intercepts. The volume of the soda will never be 0 centimeters cubed. All right, go ahead and finish it up. Let's take a look at the last page. All right, teacher works 4A and student works 4B. Predict the volume of the soda can when the temperature is 20 degrees and 60 degrees. Okay, so let's go and do 20 degrees. So we're plugging 20 in everywhere there's an x in the function. Okay, so I'm going to go to Desmos, and I want scientific calculator. So point so then that would be 355.26. Okay, all right, student works 4B. All right, write a summary of this problem situation, your model as the solution, and your limitations of the model. Data was provided for the different temperatures of a soda can and the corresponding volume of the soda can. As the temperature decreased, the volume decreased until the temperature reached 39.2 degrees. When the temperature reached 39.2 degrees or below, the volume began to increase. The data is quadratic, and the quadratic regression is v equals 0.0088 t squared minus 0.07223 t plus 356 plus 35. All right, go ahead and finish it up. All right, go ahead and finish it up and have a wonderful Wildcat day.